So now let us see some examples, a few examples on how we use the basic definitions of average and instantaneous values of speed and velocity. We see how we use the basic definition that we have studied in the previous video into some questions when practical situations come into picture. So we start with the first example, which says that let's say there is a body which moves along a straight line in such a way so that it travels with a speed v1 for a certain time t, and then travels with a speed v2 for the same time t after this, and in the process it travels a certain distance, let's say. So we are supposed to find out the average speed that this body will have. V average is what we are looking for. Now understand that if we assume that, let us say, the body travels a distance s1 in the first half of the time and it travels a distance s2 in the second half of the time, then since the two speeds with which these distances are travelled are different, the distances s1 and s2 will in general be different from each other, right? And we can find them out actually. We can find out S1, which is the distance travelled with a speed v1 for a time t, it will be equal to speed into time, so v1 into t, whereas the distance s2, which is travelled with a speed v2 for a time t, this distance s2 will be v2 times t, speed into time. So that if we try to find out the average speed, v average, which by definition is the total distance covered by the total time taken, all we need to do is add these quantities here, get their values. So S total, the total distance travelled here, as we can see from the point A, the initial point, to the final point B, the total distance travelled will be S1 plus S2 divided by the total time taken in travelling this whole distance. As we can see from the figure, it is t plus t, t for the first half time and then t for the next half. Now what we need to do is we need to substitute the values of S1 and S2 in terms of what we have been given, v1 and v2 and t. So we can write S1 as v1t plus S2 as v2t divided by t plus t, which will be 2t, and we can see that this will reduce down to v1 plus v2 by 2 after cancelling out t from both the numerator as well as the denominator. So what we see here is that in case a certain distance is travelled with two different speeds but for same intervals of time, the average speed comes out to be the average value, the mean of the two velocities. It's v1 plus v2 by 2 that we are getting as a result. We can remember this expression as a result and we can use it directly into questions wherever we have the same situation. Next is, for a similar motion, we have a small difference now. Let's say the same body travels a certain distance along a straight line in such a way so that now it travels with a speed v1 for a certain distance s, a certain distance it is travelled with a speed v1, and then it travels a further same amount of distance s with another speed v2. So this time the two distances that are travelled, they are equal and they are travelled with two different speeds, v1 and v2, and now we are supposed to find out the average speed of the body. See that there is a slight difference in the two situations. In this case, see that since the distance travelled in both the cases are same but the speeds are different, the time taken to cover these distances will be different now. So if we assume, let's say, that t1 is the time taken by the body to cover the first s distance, we can write t1 is equal to the distance s by the speed v1. Whereas if time t2 is taken to travel the second set of distance, we can write t2 as the same distance s by the speed v2. And now we can go by the same basic definition of average speed. Average speed by definition is the total distance travelled by the total time taken by the body to travel that distance. Here from this figure we see that between the initial and the final positions A and B, the total distance travelled is s plus s, that is 2s, divided by the total time taken here is t1 plus t2 and this time we need to substitute the values of T1 and T2 from the above expressions here. So, 2s divided by T1 is s by V1 plus T2 is s by V2, and when we solve this expression, s will cancel out in the process and we will get 2 V1 V2 over V1 plus V2. You can check the calculation for yourself, it will just take a minute. This is the expression that we will get for the average speed of the body this time. Do you understand what this expression is? This expression is the harmonic mean of V1 and V2. By definition, it is 2 by V average is equal to 1 by V1 plus 1 by V2. It is this kind of a mean, right? Or we can also write this as 1 by V average is equal to 1 by 2 times 1 by V1 plus 1 by V2. So, it is the mean of the reciprocals of the two speeds, that is equal to the reciprocal of the average speed. This is called harmonic mean. So, in this case, when the two distances travelled are same, but they are travelled for different times, this is what we get as the average speed. This expression also you can remember as a result, it can be directly used into questions. Let us take another example now. So, the next example is a car travels in the eastward direction with a speed of 40 kilometers per hour for 1 hour. Okay. And then it turns southward and travels with a speed of 30 kilometers per hour for another 1 hour. The question is to find out the average speed as well as the average velocity of the body, average speed and the average velocity. So, how do we proceed? First thing that we can observe here is, if the car travels with a speed of 40 kilometers per hour for 1 hour, it will actually travel the distance of 40 kilometers in this first 1 hour. So, if we take the first displacement S1 as S1, it will be 40 kilometers per hour due east, because the car has moved in the eastward direction. Whereas the second motion is towards south and it is with a speed of 30 kilometers per hour for 1 hour. So, the second displacement S2 will be 30 kilometers in the southward direction, right. So, this distance travelled is in kilometers only, not in kilometer per hour. So, 40 kilometers towards east and 40 kilometers towards south. These are the two displacements that the car would have, right. So, before we move on to displacements and find out the average velocity, let us look for the average speed. The average speed here by definition is the total distance travelled once again by the total time taken. So, see that in this case the total distance travelled is 40 kilometers towards east plus 30 kilometers towards south, that is a total of 70 kilometers, divided by the time taken in this covering this whole distance is 2 hours, 1 hour for 40 kilometers and 1 hour for 30 kilometers. So, 2 hours. So, we are getting 70 by 2 or 35 kilometer per hour as our average speed. Whereas, if we try to find out the average velocity, that by definition is the total displacement by the total time. Now, how do we find out the total displacement? We can use the triangular law of vector addition. We can draw the figure corresponding to triangular law. We know that the first displacement S1 vector is 40 kilometers due east, whereas the second displacement is 30 kilometers towards south. So, we can see here that the net displacement here will be in this direction, which using the Pythagoras theorem we can see that it will be 50 kilometers, isn't it? This is S2 here. So, S, the net displacement, magnitude of that will be square root of 40 squared plus 30 squared using the Pythagoras theorem, that comes out to be 50. So, the total displacement here is 50 kilometers and the time taken is the same 2 hours itself, right. So, it will be 2 hours taken to cover this displacement. So, you see that the magnitude of your displacement will come out to be 25, but what about the direction? We will talk about the direction as well. 25 kilometer per hour is the magnitude of the displacement if we talk about only the magnitude. Now, the direction of the average velocity we can find out. So, understand that the direction of average velocity, first thing is it will be the same as the direction of the net displacement. What is the direction of the net displacement? It is from the starting position A to the ending position C. So, along the direction AC is the net displacement and so is the direction of the average velocity as well. Now, what is this direction? How do we find this out? We can find out the direction of vector AC by calculating this angle theta that the vector AC makes with, let us say, the vector AB, the horizontal direction, the eastward direction. How do we get that? From this figure itself we can observe that tan theta can be written as the opposite length, which is BC, which is 30 kilometers, by the base length, which in this case is 40 kilometers here. So, 30 by 40, which will be 3 by 4, and hence you can say that the angle theta, that the resultant direction of the displacement as well as the direction of average velocity makes with the eastward direction, can be written as tan inverse of 3 by 4. This is how you can express the direction of the average velocity. Next example. This time we have the distance travelled by a body in time t given by s is equal to 3t squared. This is an expression of s in terms of t, the time. So, this is all that is given to us and we are supposed to find out part A, the average speed from t is equal to 0 to t is equal to 5 seconds. So, for the first 5 seconds we are supposed to find out the average speed of this body. We are also supposed to find out the average, not the average, the instantaneous speed of the body at t is equal to 5 seconds, let us say. So, the average speed and the instantaneous speed, both we are supposed to find out. Average speed for a big time interval, for a time interval of 5 seconds from t is equal to 0 to t is equal to 5, and the instantaneous speed at an instant of time. Which instant of time? At t is equal to 5 seconds. So, let us proceed one by one, stepwise. Once again we will use the basic definition. V average, the average speed by definition is the total distance travelled by the total time taken, right? Now, from t is equal to 0 to t is equal to 5, how do we find out the distance travelled by the body? If this expression gives us the distance travelled in any time t, if we just put t is equal to 5 over here, we will get the distance travelled in 5 seconds, isn't it? So, we can first find out s, the distance travelled in t is equal to 5 seconds. Substituting t is equal to 5 in the above expression, we will get 3 into 5 squared, which will be 3 into 25, that's 75 meters. And now we can use that 75 meters as the total distance travelled by the body in the first 5 seconds divided by the time taken, which is 5 seconds itself. So, see that we are getting the answer simply as 15 meters per second for average speed, right. Now, we move on to the second part of the question, finding out the instantaneous speed of the body. V instantaneous, or simply written V, by definition is ds by dt, the rate of coverage of a distance travelled per unit time, which mathematically is the differentiation of distance with respect to time, right. So, we have the expression for distance travelled, which is this. So, we understand that this means we are supposed to differentiate the expression 3t squared with respect to time. Now, we move on to the mathematical part of the question. How to differentiate this function? 3 being a constant will come out, and we are supposed to differentiate the term t squared, which using the standard formula for differentiation, we will have differentiation of t squared as 2t, right? So this comes out to be 6t as the expression for instantaneous speed as a function of time. We are supposed to find out the instantaneous speed at t is equal to 5. So all we need to do is substitute t is equal to 5 in the expression. 6 into 5, that is 30 meter per second. So the instantaneous speed of the body at t is equal to 5 seconds is 30 meter per second. Okay, so this is how we get the second part of the question. One more example let us take. This time we have a graph with us. There is a figure that shows us the speed versus time graph of a body. This is V versus T graph. T, the time is given in seconds, and V, the speed is given in meter per second. The graph is like this, let us say. It shows that there is a body which moves with an increasing speed till t is equal to 4 seconds. This is at t is equal to 4, and the speed that it gains in 4 seconds is given to be 20 meter per second. The question now is to find out the distance travelled by the body in 4 seconds. Okay, so how do we proceed? Find S in the time interval of 4 seconds. So, do we remember discussing in the previous video that if we have the speed time graph with us, the area under the speed time graph gives us the distance travelled by the body. So, here this is the graph corresponding to speed versus time. What will be the area under this graph? It will be this area. For t is equal to 4 seconds, this shaded region, shaded area will give us the distance travelled by the body. So, in this case we can say that if we can just find out this area, that will be the answer. So, S, the distance, is given by the area under the VT graph, which from the figure that we have in hand will be the area of this triangle that we have. Area of a triangle is half into base into height. So, this will be half into the base length of this triangle is from 0 to 4, this 4 seconds of time interval. So, 4 into the height of this triangle is this length, which is the same as this 20 meter per second of speed. So, 20. And since we are looking for a distance travelled, the unit for this will be meters. So, it will be 2 will cancel out and you will get 40 meters as your final answer for the distance travelled.